Hi everyone, I'm back with another circuit question example again. So it says in figure 5, solve the voltage across the capacitor V0T by superposition theorem. What does superposition theorem mean? Superposition says if you have multiple sources, like we have here, we have a current source, and then we have a voltage source as well here. If you have multiple sources, what you can do, instead of solving this complicated problem of having all the sources together, you can just consider one source at a time and then solve it, and then the total solution is going to be addition of your solution from each part. So for example, here, let's do this. Let's start by looking at the circuit first by considering this is a step 1, just the current source. Okay, step 1, just the current source. So we are going to draw the circuit, and then as you can see, it's going to tell you the phasors and everything. So this is 5 with 10 degrees, okay, when you want to consider the phasors, and then omega is actually 20. This is all you get here, because we always assume that our sources are going to be 5 cosine omega t plus the phase, right? Let's call it phi 0. And then here omega is important to know. It's 20 because we are going to use it to find the phasors for the capacitor and the inductance. And this is 10 ohm. Then we have half a farad here, and then we have 2 henries here. Okay, so if you want to do I didn't want to do replace the capacitor and the inductance with the phasor, but we can do that as well. So impedance of the inductance is J omega L, so it's going to be 2 multiplied by 20 by J, it's going to be 40J. Okay, I hope you're not cursing me for using this color. I really like I really like the color, but I hope it's clear to you guys. Okay, and then this one is going to be 1 over J omega L, omega C, which is going to be 1 over J 20 half. So it's going to be minus 0.1 J. Let's draw it again, just so that always draw multiple times, as many as you need, so that you don't confuse the solutions. It's the worst thing to do all of this and then lose points because you lost something between the steps. Minus 0.1 J. Okay, so we have this current coming in here, it's coming in here, and then the current, in order to find this voltage across here, basically, either we say the voltage across the capacitor is actually the voltage across the inductance too. So we need to do a voltage division. Right now the inductance and the capacitor are in parallel. So we can do another replacement and say this is 5. Actually, no, we can do a current division, We can do a current division because this current of 5 with the phasor 10, with the phase 10, is going to go between them, right? The current division would tell us that, let's call this IC and this is IL, right? And our total current is the 5 from the current source. So our IC is going to be 40J over 40J minus 0.1J multiplied by IS. This is, let's call this IS. Oh, what happened? This is exactly like having two resistors. Let's say R1 and R2. And you have a current IS coming in, right? How do we do the current division? We know the voltages has to be equal, right? If we call this one I1 and this one I2, we know R1 I1 is equal to R2 I2. So then I1 has to be R2 over R1 multiplied by I2. Then IS, which is equal to I1 plus I2, has to be R2 over R1 I2 plus I2. So I2 is going to be R1 over R1 plus R2 over IS. So the current that is going through the second resistor is going to be this resistor value over the summation. So that's how IC is going to be 40J, which is, let's call it R2, multiplied by over the summation of the two. So IC is going to be 40J over 39.9 JIS. So again, it's almost the same. So it's going to be 40 over 39.9, whatever, right? Let's call it 1.00. I can do 40 over 39.9, 025 IS. IC is going to be 1.0025 multiplied by 5 over 10. And then we wanted to calculate V0T. Okay, so V0 is going to be, these are the phasors, remember. V0 is going to be IC over J omega C. So 0.025 multiplied by 5, 10 over again 0.1 J. Oh, sorry, no, multiplied by 1 J minus 1 J. So right now, what we have to do is be careful about the phases, because we have a minus J. Minus J is like minus 10 degrees, 90 degrees. So we do the amplitudes all together, 1.0025 multiplied by 5 multiplied by 1.1. That's about 0.5. But the phase is going to be, I didn't include the minus here. So minus J, we have the phase of minus, we have the 10 degrees plus the phase of minus J, which is minus 90 degrees. J is 90 and minus is going to be minus 90 degree. So then we have 0.15 minus 80 degrees. Okay, so this was only if we consider the current source. We have to remember this one. Then we have to do, before we get too far away, let's do the step 2, just the voltage source. Okay, so let's draw this again with the voltage source. When we said just a current source, what did we do? We removed this one, right? We removed it. We open circuited it. Okay? Now, when we want to remove, if this becomes open, oops, what did I do? When the voltage source becomes open circuit, it's as if it's not there, right? So it doesn't matter. We can just remove it. Now let's see the current source. When the current source becomes, you remove it, how do you remove the current source? You short circuit it, right? So we have voltage source, we short circuit, we open circuit it. Voltage source, the current source, we short circuit it. So here we have Vs, which is 10 sine 20t. So because it's sine, the phase is going to be 90. So this is because we had sine omega t. Okay, so then we have the same thing, minus 1j, 40j, and then now when we short circuit, this is because of the current source. We short circuited it, the 10 ohm comes across. But since all of these are in parallel, then this is easy. Vc here is going to be exactly as Vs. So it's going to be 10 is the phasor of 90. So the total Vc is going to be, this is, let's call this Vc2. This is what is this? Vc1. So it's going to be Vc1 plus Vc2, which is going to be minus 80 degree plus 10 with 90 degree. How do you solve this? Again, you can convert them to real and imaginary parts. This is half of minus 80 is going to be cosine of minus 80 plus j sine of minus 80 degrees plus 10 cosine of 10 degrees, which is going to be 90 degrees, sorry, which is going to be 0 plus j sine of 90 degree. Again, even from the phasor, we get the Vc, which is going to be the same thing as the Vs, basically, which is sine, basically. So here, 80 degree, we can calculate all of this, and then let's say we get a phasor. Oh, what is happening? So here we have half of cosine of negative degree is the same as the positive one, but we can calculate that cosine of, we have to convert it to the radians. Be careful if you're using a calculator to convert that to radians, and in order to calculate a degree to radians, you have to multiply it by pi over 180. So 80 multiplied by pi over 180, and then cosine of 1.39. So this is about 18 j, and then you can use sine of an angle is 1 minus cosine of that angle squared, so 1 minus 2 okay, so this is J 0.9676. So we have 18 multiplied by half. Again, this 10 is really dominant, but we can solve it, right? So half 0.5 multiplied by 0.18 is going to be 0.009 plus J 9676 multiplied by half is going to be 4838 plus 10J. And then we say 0.09 plus 10.48 J. We already said that. So then we can calculate, we have to find the amplitude and the phase of this thing, which is going to be, so this is VC, amplitude of VC, I'm going to remove this. Amplitude of VC is going to be 0.09 plus 10.48 to this, and then angle of VC is going to be tangent of 10.48, sorry, 8 tangent of this over 0.9. And then when you solve that, then you can say VCT is going to be amplitude of VC cosine of 20t with the phase of VC, just like we had it here. You can add the plus here, sorry. Plus phase of VC. And that's how you end this with the phasors. I hope this was helpful to you. Come back to the channel to learn something else. Bye.